Assalamualaikum and hi everyone. Today I gonna discuss about topic 7, learning outcome 7.1. Question number 1, calculate the weight of an astronaut whose mass including the spacesuit is 72 kg. Given that the acceleration due to the gravity from moon is 1/6 g Earth. Question 1a, from weight equals to mass times gravitational acceleration. So mass is 72, g moon is 1/6 g Earth. G Earth is 9.81, so will equals to 117.72 Newton. Okay, so B, the weight in the Earth, W equals to mg, m is 72, g is 9.81. So we have 706.32 Newton. Okay, question number 2. At what distance apart would two equal masses of 150 kg need to be placed for the force between them to be 2 power of -5 Newton? If one of the masses is decreased and the distance remain unchanged, what would happen to the attraction force? To answer question number 2, we need to use the gravitational force. F equals to G m1 m2 over r squared. So we need to find out the r. Okay, we substitute all the values. The mass is 150 and the force is 2 power of -5 Newton. Okay, then we have the answer is 0.2739 meter. For number 3, so we use AG equals to GM over R square. So substitute all the information given. This one is the universal constant. The mass is 3.3 power of 23 kg and the distance is 2.439 power of 6 square. Then we calculate, we get 3.7 ms -2. Okay, that one is for A. For B, the 3B, what is the gravitational field strength at 0.3 power of 6 meter from the center of the planet? Okay, we can use the same formula. Okay, substitute all the information given. 6.67 power of -11, 3.3 power of 23, then the distance given is 3 power of 6 square. Then we have 2.446 ms -2. Now let's look at question number 9, which is cover learning outcome 7.2. Calculate the gravitational potential energy for a mass 30 kg at height 36,000 km from the surface of the Earth. Okay, so this one, if I draw the diagram, here is the radius of Earth, then the mass, the object here, of mass 30 kg, and the distance r is 36,000 km from the surface. Okay, from the surface of the Earth. To calculate the gravitational potential energy, we can use U equals to G mm over r. Then we substitute all the information given. The mass is, okay, mass of Earth times mass of the object over r. R is, okay, r is the distance from the center of the Earth until the position of the mass. So we need to plus RE plus the R. Okay, I put here is H lah. Okay, H. RE is 6.4 power of 6. 6.4 power of 6. H is 36 kilometer. So then we calculate, we get the answer 282.217 power of 6 joule. Now let's look at question number 12. A 1000 kilogram satellite is in an orbit 350 kilometer above the Earth's surface. Calculate the speed of the satellite, the period of the satellite, and the radial acceleration of the satellite. Okay, so for 12a, we use formula of V equals to Gm over R. Okay, then we substitute. Okay, remember that the R is from the center to the satellite. Okay, so means that Re plus H will equals to R. Re is 6.4 power of 6 plus 350 kilometer. So the answer is 7.687 kilometer per second. Okay, for period, we just use T equals to 2 pi R cube over Gm. Okay, 2 pi. Okay, remember R is the distance from the center, means 6.4 power of 6 plus H 35,000 kilo, 350 kilometer or 35,000 meter cube over G. The constant is 6.67 power of negative 11. Then the M is 5.98 power of 24. Okay, so the value for the radius of Earth and the mass of the Earth has been given in the list of constant. Okay, you can refer from the list of constant to get all the constant values. Okay, then C, the radial acceleration, we just use AC equals to V square over R. Okay, we substitute because the velocity we already calculate from A, then 7.687 kilometer per second, so we set power of 3, and then the R is equals to 350,000 plus 6.4 power of 6 will equals to 8.754 meter per second square. Okay, settle. Now number 13. A 7,000 kilogram satellite move in a circular orbit around the Earth with speed of 6,000 meter per second. Determine the satellite altitude from the Earth's surface. Okay, so now to answer 13A, we need to use the formula of V equals to Gm over R. So, means that R equals to 6.67 power of negative 11 times 5.98 power of 24 over V. Okay, V square. Okay, then we get 11.08 power of 6 meter. What we get here is the distance from the center to the satellite, but the question need to determine the satellite altitude from the Earth's surface. So what we need to do is we need to find out the H, which is H equals to 11.08 power of 6 minus RE. Okay, RE is the radius of the Earth, which is radius of the Earth is 6.4 power of 6. So then we calculate, we get the answer is 4.68 power of 6 meter. Okay, this one for A. Then we need to find out the period of the satellite orbit. So we use T equals to 2 pi square root R cubed over GM. Okay, we substitute all the values, then we get the answer 11.603 power of 3 second. That's all for chapter 7. Thank you.